Okay, let's start. Now it's chapter 4. Good morning. Assalamualaikum everyone. Last time we had done chapter 4. Now we proceed to chapter 5, which is differentiation and integration. Okay, we will focus on integration first. Now, integration, you have learned in statistics, is it? Or calculus? Or maths? Maths. Integration. So, integration in maths, you learn doing like this, right? So, fx, some things. Right, so integration. This is normal integration, but in numerical way, we do it different way. Okay, where it is already integrated the value, and you will get some trapezoidal rules, Simpson's rule, and unequal segment. Okay, it depends. Now, the function of integration in numerical is to find area under the curve. Okay, so in numerical, integration is to find area under the curve. So let's say you are given this function. This is your function, fx. Now you have to integrate the function from a to b. Okay, so a is your lower range, b is your upper range. Now you need to find what is the area under the curve for this range. Okay, that is integration in numerical. So you need to know what is your fx, what is your a and b. That is the basic things. Okay. Now in integrations, we will learn two rules, trapezoid and Simpson's rule. Okay, trapezoidal rules, it relates to the trapezium. Still remember what you learned? Trapezium. How to find the area of trapezium? Area of trapezium. Still remember? Julius, how to find area of trapezium?
The general one.
General one area.
Minus up and down, and then the
Upper and lower over 2, right? Is it? Then multiply by the height. Okay, so this is the general formula to find the trapezium. Last time you learned during your secondary school. So the height is over here. Height. Right. Then length, upper length, and this one. Average of this multiplied by height over 2. Okay, so that is the trapezium area. So you will apply the same area formula for this trapezoid rule. Okay. Now for Simpson's rule, later on you will see there are two types of Simpson's rule, 1/3 and 3/8 rules. Okay. Unequal is the mixture of all rules. It can be trapezoid plus 1/3 Simpson or plus 3/8 Simpsons. Okay. This one all to find area under the curve. Okay. Now this is the common function that we have came across during Newton interpolation last time. A here is similar to B. Okay, B0, B1x, and Bnx. Okay, this general function from Newton last time. That's why it also Newton integration. Okay. Now this one, as we know, integration is to find area under the curve. So we have a first order polynomial and second order polynomial. Here it means first order means n equals to 1. Correct. How many points? N equals to 1, 2 points. So it is a linear. Okay, 2 points, linear. So you see this, that's why here, this is n equals to 1. So you have 2 points, A and B. Lower range, upper range, 2 points. Then the line over here, you can see it is a straight line, which is the linear. So this is your fx, the function of that curve. Okay, so to find area under the curve for this function using n equals to 1 linear, you will only get this part, area under the curve, within that area. Okay, this is linear n equals to 2. Now, the actual line is this one, the curve. Area under the curve from linear, you only get this part. Okay, so this part is the error. This is the error. Okay, so this is error. Okay, compare if you have n order equals to 2. Second order, 3 points. Okay, so now you have 3 points. Wait, just don't, I don't want you to get confused. Okay. Let's say x0, x1, x2. Okay, 3 points. Now, n, apart from the order, n is order, also equals to section, also equals to segment. Okay, so n equals to 2 means it has 2 segments. 2 segments. Okay, 1, 2. Okay, 2 segments. Okay, here you can see when you have 3 points, 2 segments, your error is lesser compared to n equals to 1. So this part is the error. Okay, so this pictured the Newton interpolation last time. The higher the order, the lesser the error to the actual value. Okay, again, n equals to 2, you have 2 segments, 1 and 2. So it covers this area. Okay, so the yellow part is the error. Compared to n equals to 1, error is larger. Okay. Okay, this one the same as I explained. Now, if you have more area, more segments, let's say here you have 7 segments. 7, so here n equals to 7. N, remember n is the order, section, segment. Okay. So far clear the concept? Okay. This one, if linear, first order, we only have up to x power 1. Okay, which is 2 points. Now, straight line can be represented as this. So this is the area covered for linear, x0, x1. Okay, so the function it will form this one. This is B0, B1 from the Newton order last time. Okay, same. Now, how it represents to the integration of trapezoid rule. Okay, so this is the function from the linear just now. Integrate from A to B. Okay, integration of this function will form this equation, trapezoid rule. So in numerical, you straight away use this equation. You don't need to integrate in maths way. Okay, straight away use this equation for trapezoidal rule. Single application. Single application means n equals to 1. Later you will see. Okay, later you will see. Still working. Later you will see multiple application where n equals to 2 and more. Okay, when multiple application, different equation. Now again, this is the trapezoid. N equals to 1, so 2 points. A, B, or X0, X1. Okay, it depends on how you label your data. Now, how this one looks like trapezoid? This is the upper and lower. Okay, this part, the base. This one. The AB is your H. Okay, can picture that? So AB is your height. This part is this one. Okay, that's why we use trapezoidal rule, trapezium equation. Okay. Now, this one as I explained, this is this part, the base. Okay, this is the width which equivalent to A and B. Okay. Now the error over here, I will not focus much on this equation. The error, we just use like previous error. Like the, for true error, you use true value minus approximate value over true value, right? Okay. If approximate error, you use the new value minus old value over new value. Okay. Just don't focus on this part because this one you need to do double differentiation of the function. It is a long way. Okay, you can see the details in your textbook. Be sure. But eventually, final answer somehow quite close to this equation as well. Okay. Now, we try one example so that you understand how to apply the trapezoidal rules. Now, single application. Remember, this term, it brings something. It means something. Single, multiple. Single means n equals to 1. Okay. Now, this one, it asks you to use the equation to numerically integrate. So numerically integrate means you need to use the trapezoid rule. Not the normal integration. This is the given function. Okay, in integration, you need to identify what is your fx, the function that you want to integrate. It's either given by the equation or is given in table form, the data form. Okay, then find what is your range, A and B. Okay, find your A and B, the range. And third one, what is your N? In this case, N equals to 1. Okay, now this is the true value. How to get the true value? How to get the true value? Calculator, yes. Integrate the value over here. How do you use calculator? Okay, I just share with you. Not this one. Okay, I just want to show also how to find. Have download one calculator. Wait, where is my calculator? Here. Okay. I want to make sure all of you know how to integrate using calculator. This model, because I use this model, so I'm familiar with this model. Now, how to integrate using calculator to find the true value? This is you need to find out first. Okay, so integration. Okay, press the integration, then key in your function over here. Key in your function. X alpha x, okay, minus 200 alpha x power 2, okay, plus 675 alpha x power 3 minus 900 alpha x power 4, okay, plus 400 power 5. Then, after you key in the function, comma, okay, comma, use this comma. Then key in your range, A and B. A is 0, comma, B, 0.8. Okay, then, why is it different? You should get this one, 1.64. Wait, let me check. What's the difference over here? Can you get 1.64? Which part? Oh, okay. This one should be plus. Correct, yes, thank you. 6, 7. Okay. I still don't get it. Okay, let me try again. Should get. Okay, never mind. Let's try again. Any of you get it? Plus. Okay, let's use bracket instead. 2. Okay, comma. Put your range 0, 0.8. That is your true value. Yeah. After you get your answer, because you can refer to this whether your answer is correct or not. True value. Okay, this is true values. Now we proceed with the solution. This is true value using calculator. Now, to find the single application of trapezoid rule. So we know that single application equation is equals to this. Okay, single application. Now, we need FA and FB. FA, you need to find what is your FA. FA, A is 0. So, sub 0 into the equation over here. You will get 0.2. Okay, FB, B is 0.8. So, sub 0.8 into the X. You will get 0.232. Okay, then sub into the main equation. B 0.8 minus 0 multiplied by FA, the one that you calculated, minus FB over 2. (0.1728). So this is from your calculation. Whereby the true value that you press the calculator just now is this. So try to check what is the true error. What is the true error of this? Huh? Oh, okay, sorry. Plus, plus, sorry, plus. FA plus, not minus. Then you get 0.1728. Sorry? Okay, how do I know n equals to 1 from this term? Single application. Okay, remember, single application trapezoid, n equals to 1. But single application for Simpson later on is different. Okay, single application for trapezoid means the simplest, let's say the simplest trapezoid rules. Minimum you need to have 2 points, right? In order for you to find the area under the curve for trapezoid. Minimum 2 points so that you can find the area under the curve. So 2 points n equals to 1. One is single application. Okay, you should understand the term because last final exam I didn't give the n. I just give the term single. Simpson 1/3. Okay. Any question for this example? Clear? You need to find.
Yes.
Okay, we go to that. That one is multiple application. Okay, single, clear? Now, this is it depicted the error when you have only one n equals to 1. Okay, you see, if only n equals to 1, the integrated part just now is only this part. That's why the true error just now, how many you calculated? The true error? 89 something, right? So the true error is 89.5%. That's why you can see the error is very big. Okay? That's the purpose to use higher order, more points. Okay, next we move to multiple to improve the accuracy. Okay, so for multiple, you can see from here, okay, for multiple, A here n equals to 2 because you have 1 and 2 segments. Okay, B, you have 3 segments. C, even more. 5, even more. D, even more. Okay, until 5 segments. Okay, so the one that we want to focus is the area under the curve, how it increases from low order to higher order. Okay, then you can see as well the error. Okay, the error is decrease when you have higher order. It approach the true value. Okay. Now, if multiple, you can see over here. Show you. Now, if you have multiple, this is A, B. A and B, A is your lower range, B is your highest range, the upper range. In between is your point. Okay, so if the question gives you this part is n equals to 4. Okay, let's say n equals to 4. Remember, n is also segment. So now you have 4 segments. So to find the h, each of these you need to find the distance, the h. Because trapezoid, if single just now, if single, A and B, this is the h. If single, but now you have multiple. So the h you need to find for each segment. Each segment should have the same h, the distance. Okay. Now how to find the h is this equation. B minus A over the n, the segment. Then you get what is your h. For each segment. Okay. The higher the order, the smaller the h. Okay. Clear? Now I move to next slide. Now this is the equation when for multiple application. Okay, multiple. This is plus. Okay, multiple. So you see, multiple, it involves all segments. Because you have many segments just now. Okay, let's say that one is your segment. So here you see, from x0 to x1, x0, x1, x2, x3. So this is the area for the first segment for each segment. Okay, you need to sum up all the segments. H again should find from this equation. Okay. Now the final equation for multiple application. This is the general multiple application. Okay. Why it sum up like this? Because the n, it can go any number, the order. Okay. Now this part, the intermediate part, multiply by 2. This is the first segment and the last segment. Okay, let's say you have, for example, 1 up to 10 segment, for example. So here is the part where 2 fx, summation of the 2 fx. The last segment and the first segment stand alone. First fx and the last fx stand alone. The intermediate multiply by 2. Okay, then over, okay, this part over 2 multiplied by n. Or, okay, or we know that h is b minus a over n. Okay, this part, this b minus a with the n is equal to h. Okay, you can also simplify as h multiplied by the function. Over 2. Okay. Okay, up to there. Single and multiple. Different equations. Okay. Now I move to the example. Find the definite integral for the following function for n equals to 4. Okay, it gives you the n equals to 4. We know that you must have how many points? How many points? N equals to 4. 5 points, correct. 5 points. See, this question, it doesn't mention the axis, the points. You need to find on your own. It only gives you the A. This is the A. This is the B. The lower range and the upper range. Okay, so you need to find out what is your axis and your f-axis. X start with the lower range, which is the A. Okay, so X naught, remember we have 5 points. 1, 2, 3, 4, 5. Okay, until X4. X naught and the last point, okay, X naught is A, last point is B. Okay, we find the X value first. Now, A we know 2. X4, which is the B, final point will be 6. Now, we need to find the intermediate points. How to find? Okay. Here's the thing. You need to understand how it can get to that application. Now, from 2 to 6 with 4 segments. Okay, each of these same H. Okay, so we need to find what is the h in order to know what is your points. X naught here is x1, x2, x3, x4. Okay, to get x1, x naught plus h, correct? To get x1, x naught plus h. X naught is the previous value plus the distance, then only you get the next value, next point. Now, we need to find what is the h. Okay, so find your h from this equation. Correct. B is 6, A is 2, divide by N is 4. So you will get 1. Your H is 1. Correct? Correct. Yes. So X naught is 2. X1, 2 plus 1 is 3. So X2, 3 plus 1, 4, 5. Okay, that's how you get your point. Once you get your point, you need to find your fx. How to find your fx? Huh? Correct. Yes. Your fx function is this. This is your fx function. Set x. Okay. So fx for first point here set 2. Then you get the value. Sub in your x to find the fx. Okay, this is the case when fx is not given. So you need to find from the function. Okay, try to calculate. Now, once you get your x, fx, this is multiple application. So sub into this equation. B is 6 minus 2. Okay, or you can just straight away use your h. Okay. Now let's just use the h value. 1, then multiply your fx naught is set 2. Okay, plus 2 multiply the summation of the intermediate. Okay, now intermediate is this part only. Set 3, set 4, set 5. The intermediate. Okay, then plus the final function value, set 6. This one stand alone. Huh? Okay, then this thing divide by 2. So I get correct. Okay, this why I don't multiply by the n, because I use the h straight away. H is b minus a with the n already. B minus a over n. Then this thing over 2. Where b minus a over n is your h. $7.9. Get? Okay, how to know your answer is correct? Find the true value. Okay, so here roughly you will get 7.9. So what is value? So if it is approaching your true value, then your answer should be correct. Use calculator function integration only, faster. Okay, now you can understand. We try this example. Same as the previous single, but now multiple application. Okay, multiple application, use 2 segments. 2 segments, n equals to 2. So how many points that you need to have? 3, correct. So find out your x1, x0, x1, x2. Then your f-axis. Okay, wait, we go step by step. First, your n given as 2. Find your h. Okay, n equals to 2, so find your h. After that, only you can find your points. Okay, h is b minus a, 0.8 minus 0 over 2. 0.4, correct. Okay, so that is your h. Next, find your points. x0 is your a, which is 0. x2 is your b, which is 0.8. Alright, x1 is 0.4. Okay, find your f-axis by sub the x value into the main function. Okay, this is your main function, so sub your x over here. You know how to set the equation in the calculator so that you can calculate faster. Okay, I'll show you. For those who still not sure, okay, set your equation. This is your main equation. Okay, so set your equation. I prefer to use bracket to avoid any error. So x over here, you can put x or a, any letters. Okay, then just key in your equation first. Okay, key in your equation, then press calculate. Key in your x, 0. That is your value, 0.2. Okay, then next, just press calculate. Key in your next x value, 0.4, equal. Okay, 2.456. Next x value, calculate, 0.8, equal. Okay, so if you know how to use your calculator, your calculation will be faster. Okay, so once you have all the values, x's and f-axis, sub into the main equation of integration, multiple application. Okay, multiple application. Formula will be given, yes. Okay, so fx naught is 0.2. This is 0.2. Now, the intermediate part is only fx1, which is this. Fxn is the last point. Again, correct. 1.0688. True error? True error, not true value. True error. Huh? 1.64 is true value. True error. The one is approximate value. True error. True value minus approximate value over true value.
Okay.
34.9, yes. Okay, so you see n equals to 2. This is the true error. Previously, n equals to 1 is 89 something. That's the first example. Okay, so it reduced by half when you increase the segment. Okay. Can. Okay. Now, this example is used up to n equals to 10. Okay, you see the true error when n equals to 10, 1.6. So the higher the order, the lesser the error. Okay. Now we try this. This one, most of the exercise I extract from the textbook. You can refer to the textbook. So this, it asks you to evaluate the following integral. Analytically, this is to find the true value. Okay, then by single application. Single application n equals to what? 1, right. Then multiple application with n equals to 2 and 4. Okay, for C, let's try n equals to 4. Okay, let's try n equals to 4. D and E, this one ignore first. Now, try to find the true value using calculator. Remember, when it involves sine, cos, or tan, change the mode to radian. Okay. Now, to find the true value, integrate, key in your function. Wait, this one I haven't, wait, I changed the mode first. Radian. Okay. Then integrate it, key in the function, cos x, okay, comma, 0, key in the range, pi over 2. Pi. You get the same, 16. Same, 16.566. Mode radian, remember the mode is radian. 16.566. If you get 18, you are using mode degree. Okay. You get the same? For the true value. What you get? Huh? 18, then your mode is degree. If you get different from mine, I will check your mode. Okay, let's see. Degree. 18. Okay, if you use radian, it will be 16. Okay, proceed with the single application. Single application of trapezoidal. So this is the equation for single. What is your A? 0. B? Correct. This is your B. Okay, this whole thing is your fx. Okay, so your n1, x0, x1. x0 is 0, pi over 2. So your fx key in into the function. Okay, you can set the equation. Okay, then just calculate, key in your x. First one is 0. You'll get 12. Next one is pi over 2. Calculate, then key in your x. We get 8. Okay, then subs into the equation. which means 5 points. Okay, for C, n equals to 4. So find your H first. B minus A over n. N is 4. What you get for your H? Julius, what you get for your H? Divide by 4. Okay, divide by your n. 0.39. Right. 0.39. Okay. Then from there, list down your points. X, okay, X not 4, you must have 5 points. X naught is your A, which is 0. X5 is your B. Not X5. X4 only, until X4. 5 points. So X4 is pi over 2. Okay, so X1 is 0.39. X2 0.39 plus H. Okay, so 0.78. X3 1.7. 1.17. Okay, then subs your x's into the equation. Okay, just now we had still drawn. Oh no. Set the equation, then just key in your data. Okay, 8 plus cos 4 cos x. Okay, calculate 0 for the first point is 12. Calculate input the next point 0.39. Okay, 11.69. Okay, Then sub into the main equation. $16.4151. Remember your true value just now is what? 16.566. Okay, so it is approaching the true value. That is your final answer. Okay. Trapezoid. Okay, so that's all for trapezoid. Next class, we will do one more example, which is final exam from May 2021. This one. Okay, we proceed with this, then I will proceed to Simpson. Okay, next class, one more this one, then Simpson. Okay, that's all. Thank you. For those who haven't scanned for attendance,